All right, it says consider the reaction below, and we're given the reaction and we're given the delta H value. It says what happens when more O2 is added. So what we're looking at here is Le Chatelier's principle, and we're looking at disturbances to the equilibrium. Le Chatelier's principle is one way that chemists can drive reactions in ways they want to go. And if you take organic chemistry, you'll learn about several reactions that are driven in a similar way by using excess reactants in order to form more products. But the general idea here of Le Chatelier's principle is if a reaction is disturbed so that it's not at equilibrium, the reaction will shift to re-establish equilibrium. So if you have too much or too little of something, the reaction will shift to get rid of it if there's too much or make more if there's too little. So let's take a look here. So what happens to the reaction when more O2 is added? So O2 is a reactant. So the reaction says, hey, there's too much oxygen in this reaction. The only thing the reaction can do to get rid of oxygen is to turn the oxygen into SO3. So the reaction shifts to the right towards the products. And what is it trying to do? It's trying to get rid of that excess O2 because the reaction wants to be at equilibrium. What happens when SO3 is removed? So now we have SO3, which is a product, and we take some away. If we take some SO3 away, the reaction says, hey, there's not enough SO3 here. So what can the reaction do to make more SO3? It can react this and this. So removing SO3 is going to shift it again to the right towards the products because the reaction wants to create more SO3 for the SO3 that was removed. When SO2 is added, so if we add SO2, the reaction says, hey, there's too much SO2. What can the reaction do? Well, the reaction can get rid of SO2 by turning it into SO3. And again, it shifts towards the products. Okay, so if you add a reactant or remove a product, the reaction will shift towards the products. If you add a product or remove a reactant, the reaction will shift towards the reactants. These just happen to be all in the same direction. Now, something that looks like it doesn't make sense. What happens when the pressure is increased? In this case, we need to consider the total moles of gas on each side of the equation. So in this case, we have 3 moles of gas on the reactant side and only 2 moles of gas on the product side. So when the pressure is increased, the reaction wants to shift to decrease the pressure. The only way that the reaction could shift to decrease the pressure is to make less moles of gas, because less moles of gas will have less pressure. So the reaction here will shift towards the products in order to reduce the pressure. So it's again going to shift to the right towards the products. So a lot of shifting right here, but it can just as easily shift left. And here's one where it shifts left. It says, what happens when the pressure is decreased? In this case, the reaction wants to increase the pressure. The only way the reaction can increase the pressure is by increasing the moles of gas, making more gas. And in order to do that, it's going to shift to the left towards the reactants where there is more moles of gas. So this is how gas changing the pressure works. You have to look at the moles of gas on each side. And then it says, what happens when the temperature of this reaction is increased? So the temperature of the reaction will be increased. Well, in this case, this is an exothermic reaction. How do we know that? The delta H is negative. When the delta H is negative, we could think of the heat as a product. So we're going to get this plus this yields this plus heat. Said another way, the reverse reaction is endothermic. So when we increase the temperature, we increase the amount of heat, the reaction is going to be driven away from that heat. In this case, is going to be driven towards the reactants, or generally speaking, is going to be driven in the endothermic direction. Okay, when you increase the temperature, whichever side gets the heat, it's going to be driven away from that, or said another way, it's going to be driven towards the direction that requires heat, or in the endothermic direction. So I hope this gives you a general idea of how this is going to work. Again, this is a very important concept that's used a lot by chemists practically to drive reactions in directions that we want them to go.